Hey, 8th grade. In this next lesson, we're going to focus on some advanced factoring methods for factoring polynomials of a higher degree. The last unit we looked at how to factor quadratics. Now we're going to look at how to factor some cubics and 4th degrees and 5th degrees. And so the first factoring method I want to look at that's new is going to be how to factor a sum or a difference of cubes. If you remember from Algebra 1, we had what was called a difference of squares, where if you had something like x squared minus 25, you could factor that into x minus 5 times x plus 5. Okay, so now we're going to look at both a difference of cubes, and there's also going to be a sum of cubes rule. Okay, the rule itself is going to be pretty simple once you practice it. Okay, it may look a little bit odd at first, but I promise you it's not too bad. So if you have a difference of cubes, let's say a cubed minus b cubed, that is always going to factor into a binomial times a trinomial. The binomial is always going to be the cube root of the first term minus the cube root of the second term. So for instance, if we had x cubed minus 8, okay, the cube root of x cubed would just be x itself, and the cube root of 8 is just 2. So that would factor into x minus 2 times the trinomial of your first term here, x squared, plus your two terms times each other, x times 2, which is 2x, plus your second term here, 2 squared, which is 4. Okay, and that same rule is going to apply to a sum of cubes as well. The only difference is going to be your signs. And so really the toughest part about factoring a sum or a difference of cubes is going to be the signs. And so I have a little saying to help you out with your signs when you're factoring sums or differences of cubes, and that saying is to always use your SOAP. S-O-A-P. Whenever you're factoring a sum or a difference of cubes, you're always going to follow this rule right here. For each one, you're going to start with the same sign. So in that binomial right there, for a difference of cubes, you're going to use a minus sign, okay, because this is a difference. For a sum of cubes, you're going to start with a plus sign. The next sign, which is going to be the first sign you put in your trinomial, is always going to be the opposite of the last sign you used. Okay, so in a difference of cubes, this sign right here is a positive, and a sum of cubes, this sign right here is a negative. So it's always opposite. And then the last sign in your trinomial, no matter what, is always positive. So in a difference of cubes, that last sign is positive, and a sum of cubes, that last sign is always positive. So if you remember your SOAP, same, opposite, always positive, then you're going to get your signs correctly. Okay? Before we practice factoring some sums and differences of cubes, I do want to make a list of two different types of numbers. That first list, we're going to list our perfect squares. Okay, the first 20 perfect squares. These are numbers that, if you took the square root of them, you'd get a whole number. This list needs to be memorized. And so we did a few of these last year, if you remember. 1 squared we know is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared 25. 6 squared is 36. 7 squared is 49. 8 squared 64. 9 squared 81. 10 squared 100. 11 squared 121, 12 squared 144. So those are your first 12 perfect squares. We're going to continue that list now up through 20. So 13 squared would be 169, 14 squared 196, 15 squared would be 225, 16 squared 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. So those 20 numbers right there, 1 through 400, those perfect squares, need to be memorized. You need to be able to recognize those as perfect squares because that's going to help you a whole lot when you're factoring. Now that we know this rule for a difference in sum of cubes, you also need to be able to recognize your perfect cubes. And so I'm going to have you memorize the first 10 perfect cubes. They are 1 cubed, which is 1, 2 cubed, which is 8, 3 cubed, which is 27, 4 cubed, which is 64. Notice that 64 is both a perfect square and a perfect cube. 125, which is 5 cubed. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1000. So those are your first 10 perfect cubes, and you also need to memorize those numbers and be able to recognize them as perfect cubes. Once you have those memorized, it's going to make your life a lot easier when you're factoring problems like 1 through 4. For instance, if you see 8x cubed plus 27, like we have in example 1, you should be able to recognize that both 8 and 27 are perfect cubes. So this is going to factor as a sum of cubes. Okay? To get 8x cubed, you're really taking 2x, that quantity, to the third power. Okay, 2x to the third is going to give you 8x cubed. To get 27, you're really taking the number 3 cubed. Okay, so in order to factor this is going to factor again into a binomial times a trinomial. The first thing we're going to do is put in our signs. We want to remember to use our SOAP, and so SOAP again stands for same, opposite, always positive. Our first sign right here in the binomial is going to be the same, so we're going to put a positive here. Our next sign in our trinomial will be the opposite, so a negative, and then our last sign is going to be always positive, so a plus right here. So if you do your signs first, you're likely going to get this correct. To get the binomial, you just take the cube root of 8x cubed, which we've already determined is 2x, and the cube root of 27, which we know is 3. So your binomial will be 2x plus 3. Your trinomial, to get this first term here, you square the first term in your binomial. If you take a 2x and square it, you get 4x squared. You do the same thing to get the last term in your trinomial. You square the second term. 3 squared is 9. To get the middle term, you just multiply these two terms, 2x and 3 together. 2x times 3 is 6x, and voila, that is how 8x cubed plus 27 factors. Okay, it's just memorizing the rule and using it the same way every single time. The nice thing about a sum or a difference of cubes is this trinomial here will never factor further. So you don't have to check for slide and divide or anything like that. It is just a fact. It will never ever factor further than that. Okay, let's look at number 2. For this one we have 2x cubed minus 128. You'll notice that 2 and 128, neither of those are perfect cubes. However, you can factor out a GCF for this one. 2 and 128 are both even, so we can factor out a 2 at the very beginning. And we end up getting x cubed minus 64 as our leftover part. And now we see x cubed is obviously a perfect cube. 64 is also on our list up here. So now I can factor this binomial here into a binomial times a trinomial using my difference of cubes rule. So I'm going to bring my 2 down, my GCF. Then I'm going to do my signs. The first sign is the same, so we'll put a minus sign here. The next sign is opposite, so a plus sign. And then the last sign is always positive, so another plus sign. Okay, the cube root of x cubed would just be x. The cube root of 64 is 4. So we have an x minus 4. To get the trinomial, we square the x for our first term, so that's going to give us x squared. We square the 4 here for our last term, that will give us 16. And then finally, we multiply x times 4 to get 4x, and that would be our middle term here. So this factors into 2 times the quantity x minus 4 times the quantity x squared plus 4x plus 16. For number 3, we have 64x cubed minus 1. And so the 64x cubed, we could rewrite that as the quantity 4x to the third power. 4x is the cube root of 64x cubed. And then 1 is also a perfect cube. 1 is just 1 cubed. So to factor this, we'll go ahead and do our signs first. This is a difference of cubes, so it's going to be same, opposite, always positive. The cube root of 64x cubed we already said is 4x. The cube root of 1 is 1, so our binomial will be 4x minus 1. And then your trinomial, 4x squared would be 16x squared. 1 squared is still 1, and the middle term, 4x times 1, would be 4x. Finally, number 4, we have 54x to the 5th plus 432x squared. Again, we have a GCF for this one. Not only can we pull out a 2 from 54 and 432, we can also pull out an x squared from both terms. So our GCF is 2x squared, and we are left over with 27x cubed plus 216. Okay, 27 is a perfect cube, as is 216, so now I can factor this binomial here into a binomial times a trinomial. Bring down my GCF of 2x cubed. We'll put in our signs, same, opposite, always positive. The cube root of 27x cubed is going to be 3x, so we'll put a 3x down here, and the cube root of 216 is 6, so our binomial will be 3x plus 6. And then if we square 3x, we get 9x squared. If we square 6, we get 36. That's going to be our last term. 3x times 6 is going to give us our middle term. That would be 18x. So this factors into 2x squared times the quantity 3x plus 6 times the quantity 9x squared minus 18x plus 36. So hopefully you can see it's the same exact thing every single time. It's just you have to memorize that rule and get those signs correct. Okay, that is the first factoring method I want to look at. We're going to look at a couple more on the back. These are going to be, for the most part, just an extension of what we've already done before. These aren't going to be too terribly new. For number 5 and 6 here, we're going to factor these by grouping. And so what that means is we're just going to take these 4-term polynomials, and we're going to use the box method for those. If you'll remember, we did this a little bit last year. Anytime you have a 4-term polynomial, you can factor it using what we call the box method or by grouping, as long as the last 2 coefficients multiplied together is equal to the first or the middle 2 coefficients multiplied together. So this 1 times 18 has to be equal to this negative 2 times negative 9. Negative 2 times negative 9 is positive 18. 1 times 18 is positive 18. So that means that we can factor this by grouping using our box method. So as a review, we make a 4 quadrant box here. Our first term, x cubed, goes up here. Our next term, negative 2x squared, goes here. Then our negative 9x, and then our positive 18. And so what we do is we factor GCFs out of both the rows and the columns, and we follow the signs on the outer boxes. So x cubed and negative 2x squared, the GCF of those would be x squared, and that's going to be a positive since this term right here is a positive. Negative 9x and 18, the GCF is 9, and we'll take the negative out since this box here is negative. So we get x squared minus 9 as one of our binomials. The other, we're going to do the columns now. X cubed and 9x, the GCF is x. And negative 2x squared and 18, we'll take the negative out as well. The GCF would be a negative 2. So the other binomial would be x minus 2. So this 4 term up here factors into x squared minus 9 times the quantity x minus 2. From there, hopefully you recognize that x squared minus 9 is a difference of squares. So you can factor further. That factors into x minus 3 times x plus 3, and then we're just going to bring that x minus 2 down. So this 4 term factors into 3 binomials, x minus 3 times x plus 3 times x minus 2. Okay, we'll do the same thing on number 6. We want to check and see if we can use grouping first of all. 2 times negative 5 is negative 10. 5 times negative 2 is negative 10, so that works. So now I'm going to go ahead and make my box. My first term is 2x cubed. Then I have a 5x, then a negative 2x squared, and then a negative 5. So 2x cubed and 5x, the GCF of that would be just x. And then down here, negative 2x squared minus 5, the GCF of that would be minus 1. So one of our binomials will be x minus 1. And then for the columns, we have a 2x cubed and a negative 2x squared. That GCF would be 2x squared. And then for this column, 5x and minus 5, it's going to be a positive 5 GCF. So our second binomial would be 2x squared plus 5. We want to check for any differences of squares or differences in sums of cubes. We don't have either of those for this one, so this is just our answer right here. Okay, for these last two problems, I just want to talk about how to factor polynomials by using one of your quadratic methods, or by rewriting them in quadratic form. And what that means is just applying some of the factoring rules we used in the last unit to some higher degree polynomials. For instance, number 7 here, we have 81x to the 4th minus 16. Now, even though this isn't a quadratic, even though it's not a degree 2, I can still use some of those rules we use with quadratics. For instance, differences of squares. You'll notice that x to the 4th is a perfect square. Anything to an even power has the possibility of being a perfect square. And then we know 81 and 16 are both perfect squares. So we can actually factor this binomial into a difference of squares. 81x to the 4th, well, the square root of 81 is 9, so we know there's going to be a 9 on both of these terms. And then to get an x to the 4th, you just take x squared times x squared. Okay, so the square root of 81x to the 4th is 9x squared. 16, we know the square root of 16 is 4, and so using our difference of squares rules, this factors into 9x squared minus 4 times 9x squared plus 4. From there, we create another difference of squares. 9x squared minus 4 is also a difference of two squares. The square root of 9x squared is 3x, and the square root of 4 is 2, so this factors into 3x minus 2 times the quantity 3x plus 2. You cannot factor a sum of squares, so the 9x squared plus 4 we just have to bring down. So this is how 81x to the 4th minus 16 factors. We do two separate differences of squares, and we get this answer here with three binomials. Number 8, we have a trinomial here, x to the 4th plus 4x squared minus 21. Well, if I were to make this problem x squared plus 4x minus 21, you'd be able to factor it pretty easily. Factors of negative 21 that combine to get positive 4, you could use a positive 7 and a negative 3. So if this were the problem, it would factor into x plus 7 times x minus 3. Now what I've done is, instead of giving you an x squared and an x, I've given you an x to the 4th and an x squared here. Okay, so really we can use the same rule to factor this type of a trinomial here. As long as the first term's exponent is twice that of the second term's exponent, you can use the same rule that we did with quadratics. Okay, so watch what I'm going to do. I'm still going to use a positive 7 and a minus 3 here, because 7 times negative 3 is negative 21. 7 minus 3 is 4. Instead of putting just x's here and here, I'm going to use x squareds. Okay, I know I have to get an x to the 4th. Here is my first term. X squared times x squared is x to the 4th. And I know my middle term, instead of needing to be an x, it needs to be an x squared. So that's the only thing I'm going to change about how I factored my quadratics originally, and now this will check out if I go through and FOIL it. Okay, so I know that was a lot of new factoring information I'm throwing at you. I've tried to make this a little bit simple by giving you a chart here, a summary chart at the end. So these are the methods, or this is the pattern you need to follow whenever you're doing your factoring from now on. Okay, you always check for a GCF first, so always look for a greatest common factor. Then, if you have a binomial or a two-term polynomial, you're going to check for the following. Check for a difference of squares, a difference of cubes, or a sum of cubes. Those are the three things you want to check for in addition to a GCF. Remember that sums of squares do not factor. From there, if the problem did not have two terms, if it had three terms, you're going to check for the following. If it's a normal trinomial, you're going to factor it like normal. If the leading coefficient is not 1, okay, you can factor it using your slide and divide method. Okay, I wrote box right here, but we know about slide and divide. And then finally, if it's a degree 4 trinomial, can you rewrite it in quadratic form, like I did 7 and 8? Can I use one of my quadratic methods to do it? Finally, if the polynomial has 4 terms, you're just going to factor it by grouping or using the box method is another way we call that. Okay, any questions you have on this, feel free to shoot me an email as always, and we'll discuss issues we had the next time I see you in class. Until then, have a nice day. You're all wonderful people. Take care.